All right, so I'm starting this video again. So we were on problem number about 8 yesterday, and we were discussing how do you write 0.67 trillion in different forms. And so a million is this number here, so that is 10 to the 6. A billion is a 1 followed by 9 zeros, so that's 10 to the 9th. Therefore, a trillion is a 1 followed by 12 zeros. So that's 10 to the 12th. So we have the number 0.67 trillion. So we have a number that is less than a trillion. So your implied comma would be there. So therefore, this is the same thing as 670 billion. So there's hundreds, thousands, millions, billions. All right, so if we would like to write this in scientific notation, that means that the decimal would have to be right there. And so we would have 6.7 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That is what it is in scientific notation. All right, so let's try it without writing all these zeros and doing it that way. So I have 0.67 trillion. So a trillion, we said, is 10 to the 12th power. So if I write it like this, but this is not in scientific notation, you would have to move that 1 to the right, and we have to remember Lars. Left add, right subtract. So I went to the right, so therefore I'm going to subtract, and so I still have 6.7 times 10 to the 11th power. The next one that we needed to do is 1B.1-1B.3. And so we have proportions. No, it's not that one, my bad. Hold on. This one, number 14. Here we go. Okay, so I have 2 trees, and their ratio of heights is 8 to 3. All right, so we seem to have a tall tree and a short tree, and they have a ratio of 8 to 3. So I can write ratios either with the word 2 or as a fraction like I did here. All right, so it says the taller tree is 20 feet taller than the other. So in math, the word is means equals. So the tall one equals 20 more than the short one. So when it doesn't say anything about the short one, we're going to infer that that one is just x. And so right here it says we can let x represent the height of the small tree. And the tall one is 20 feet taller than it, so that is saying addition. So I want to solve and find out how tall they are. And so when you have fraction equals fraction, you're going to cross multiply. So 8 times x is 8x. But on the other side, I have 3 times x plus 20. So when you're going to multiply something and there's 2 terms right here, you have to put it in parentheses because this 3 has to get distributed to both terms. So 3 times x is 3x, and 3 times 20 is 60. Now I'm doing algebra. I'm going to solve for x, so I'm subtracting 3x to the other side. I get 5x is 60. I'm going to divide both sides by 5. And I get x equals 12. And so that one is the short one. So the height of the smaller tree is 12 feet. How tall is the taller one? So it's 20 feet more than that. So I went 12 plus 20 and found that it was 32 feet. Number 15 is similar to this one, or to the prior one rather. I have 2 teen boys. Their ratio is 5 to 4. The heavier boy is 30 pounds more than the other. Determine their weights. All right, so I have a ratio of 5 to 4. So I have a ratio of the large boy to the small boy, which is 5 to 4. The small boy, we are going to represent his weight with x because we don't know that. And it says, and the large boy is going to be x plus 30. So I have fraction equals fraction, so I'm going to cross multiply. When I go 5 times x, that's just 5x. But when I multiply the other way, and I take 4 times x plus 30, if you have a numerator and there are 2 terms in it and you're multiplying, you have to put parentheses around it because that 4 has to be distributed. 4 times x is 4x, and 4 times 30 is 120. There we go. I'm going to do algebra and I'm going to solve. So I'm going to subtract the 4x over, and I get x equals 120. So the small boy weighs 120 pounds. The larger boy is x plus 30. So that's 120 plus 30. And so therefore the large boy weighs 150 pounds. All right, so on this next one, we have China's home to 2.7 million people, and they see 55 million visitors. Chicago has a population of 1.3 billion. How many visitors would they see? All right, so I'm going to kind of organize myself. I have population that I know about and visitors that I know about. I know about Chicago and China. So this is how I'm going to set it up. And before I get too far, I'm going to go to the last sentence, and it says, how many visitors could China expect? Number of visitors that China could expect. All right, so that is my unknown, so that is definitely where my variable goes. Chicago is home to 2.706 million, and they see 55 million visitors. China has 1.393 billion people. How many can they expect to see? All right, so I'm doing this on my own paper because I did not have enough room there. There's a lot of ways that you can do this. Since we're in the scientific notation way, they probably want me to say, oh, turn that into, write that in scientific notation, write that in scientific notation, write that in scientific notation. So that's what I'm going to do. But if push comes to shove on your homework, you could just write that in standard form with all the zeros, write that with all the zeros, and you could solve it that way as well. All right, so I know that the million is 10 to the 6, and the billion is going to be 10 to the 9th. So this number is 2.706 million, so that's times 10 to the 6th. That is 55 million, so that is 55 times 10 to the 6th. So the problem here, so if this number would have just been in millions as well, then you could just simply drop the words and you could just use the numbers to cross multiply. But since this has basically 3 zeros more, that's why we're having to do all this extra work. So I have 1.393, and a billion is 10 to the 9th divided by x. All right, so in math, there are so many different ways that you could do this problem. I mean, you could divide over here and you could simplify this if you wanted to, or you could cross multiply, which is actually what I'm going to do. So I'm going to cross multiply here. So I have this number times x. So you don't really need to do anything. 2.706 times 10 to the 6 x equals, and then when I cross multiply this, you're definitely going to have to use parentheses here. So I have 1.393 times 10 to the 9th times 55 times 10 to the 6th. So I'm going to focus on the right side. So on the right side, what we learned yesterday is that when you are multiplying in scientific notation, I'm going to group the number parts together and the 10 and the exponents together, and I'm going to multiply them. So I have 1.393 times 55 times 10 to the 9th times 10 to the 6th. So when I multiplied this right here, I got 76.615 times 10 to the 15th. So these are just regular numbers. You just multiply, and when you multiply and they have the same base, you add their exponents together. 2.706 times 10 to the 6 x. All right, so this x right here, that is my variable that I want to solve for. And so this is multiplication. I undo multiplication with division. 2.706 times 10 to the 6. Divide both sides by 2.706 times 10 to the 6th. So these are exactly the same, so they cancel each other out, and that's how I just get x on the left side. On the right, I'm going to divide the regular looking numbers, and I'm going to divide the exponents. So when you divide these numbers, I get 28.3130. I think that's good enough. It's a number that kept going on and on and on. And when you divide here, you subtract the exponents. 15 minus 6 is 9. Almost done. 28 is not in scientific notation, and that is what we need. So I need to remember the left add Lars. Left add, right subtract. So I need to move the decimal 1 to the left. Therefore, I need to add 1 to the exponent right there. And so I get 2.8313 times 10 to the 10th. And then I looked and the instructions said 2 decimal places. All right. 2.83 times 10 to the 10th then should be a good final answer on that one. So why did we have to do all that work? Because that unit was in millions and that unit was in billions, and that's why we had to do so much. I'm going to do one more. All right, so Oz is home to this many people and it has this many parks. China has this many people. How many parks do you expect them to have? So when I set it up, I am going to set it up with a ratio of people to parks. My first fraction is going to be Oz, and my second fraction is going to be China. My essential question is, how many parks would you expect in China? So that is my unknown. That is my variable. Oz has 1.7 million people and 490 parks. And China has 1.393 billion. And I want my answer in scientific notation. All right, so when you have fraction equals fraction, I'm going to cross multiply. Oh, no, I'm going to turn million and billion into scientific notation first. My bad. Okay, so a million is 10 to the 6, and a billion is going to be 10 to the 9th. So I have 1.7 times 10 to the 6th power over 490. 1.393 times 10 to the 9th over x. Now I'm going to cross multiply. So that times x is 1.7 times 10 to the 6th x equals, cross multiply that, 490 times 1.393 times 10 to the 9th. All right, so what I do know is that that number and that number are your plain old numbers. This one doesn't have a 10 with an exponent. But fun fact, 10 to the 0 is 1. And so, quite frankly, if you wanted to write this as 10 to times 10 to the 0, you can. You could also turn this into scientific notation. So, Lars, left add, right subtract. So this would be the same thing as 4.9 times 10 to the 2nd power. And then I have 1.393 times 10 to the 9th. I'm going to multiply my 4.9 and my 1.393. And then I'm going to multiply 10 to the 2nd and 10 to the 9th. And hold on, I did it slightly different earlier. 4.9 times 1.393. I get 6.8257 times 10 to the 11th. And I need to bring this down because I've been ignoring it for a minute. 1.7 times 10 to the 6th x. Okay, so all this work was to multiply these, a number not in scientific notation times one that was. So I decided to put 490 into scientific notation right here, so that then I could end up multiplying them and simplifying the right-hand side. I still have to solve for x, so I'm going to divide both sides by 1.7 times 10 to the 6th. So when I take this divided by 1.7, get 4.01511. I don't know how many I'm going to need. And when you divide, you subtract the exponent. I'm apparently doing math in my head already. And that gives me 10 to the 5th. And the problem said round to 2 decimal places. All right, so that means the 5 is going to round that up. And so I have 4.02 times 10 to the 5th. All right, let me know if you have any questions.